Good morning, students. We are seeing the lecture series from distributed system subjects. So in Unit 2, today we will discuss about design issues and challenges in distributed systems. So the designs of distributed system has numerous challenges, right? They can be categorized into three major categories. That is issues related to system and operating systems design, issues related to algorithm design, issue arising due to emerging technologies. So we'll see elaborately one by one. So let's start with issues related to system and operating system design. So first of all, communication is a major issue. So this task involves designing suitable communication mechanism among the various processes in the network, like RPC, remote procedure call, remote method invocation, RMA. These are all best examples for communication. So these protocols we have to design in such a way that it should support the distributed system, because distributed system contain loosely coupled system. Each machine has their own specification, right? So how exactly we are going to coordinate and communicate among this process, that is a major issue. So definitely we need to create processes that accept and adopt those independent systems. So that is communication play one important challenge. The next one is processes. So the main challenges involved in process are definitely the process and thread management. So we need to manage in both the client as well as server side, server environment. Then sometimes we need to do migration of code between system, design of software, and some cases we need to create mobile agent also. So in that case, how exactly the process are developed and adapted in the distributed environment, that create a big challenge. Third one is naming. Devising easy to use and robust schemes for names. Definitely the proper identifiers and addresses is essential for locating resources and processes, because since it is a independent systems, there is a possibility of name mismatch, isn't it? Or the two machines may have a same name, something like that. So definitely we need to create a unique identifier, and we need to name those identifier in a proper way. So that is another one challenge. Then synchronization, mutual exclusion, leader election, deploying physical clocks, global state recording. These are all some of the best synchronization mechanism, and definitely they should be adopted in the distributed environment. Then data storage and access schemes. Designing file systems for easy and efficient data. Uh, sorry, just a minute. Yeah. So designing file systems for easy and efficient data storage with implicit accessing mechanism is very much essential for distributed operation, right? So when we are sharing it, when we have a shared variable, definitely we need to ensure that there is a mutual exclusion. So whenever there is a critical region, we should follow the rules so that we can avoid deadlock and other those stuffs, right? So that challenges also play a major role in distributed system. Next one is consistency and replication. The notion of distributed system goes hand in hand with replication of data. We need to provide high degree of scalability. So the replica should be handled with care, since data consistency is a prime issue, right? Then fault tolerance. So this requires maintenance of fail-proof links, nodes, and processes. Some of the common fault-tolerant techniques are resilience, reliable communication, distributed commit, checkpointing, add and recovery, agreement and consensus, failure detection, and self-stabilization. So in upcoming units, definitely we'll see elaborately those topics. As of now, we'll concentrate only on the theory, right? Then definition. Security. So security is important concern, because cryptographic techniques we are going to impose, security channels, secure channels is essential for the sensitive applications. Then we need to regulate the access control, key management, generation and distribution of keys, authorization. That is like sometimes in some cases we may choose one particular node as a coordinator, right? So automatically we need to give more privileges for that coordinator node other than the members, right? So something like that, all these kind of group management activities, everything come under security measures. Definitely we need to ensure that everything happen in a proper secured way for the success of distributed systems. Okay, next one is API, that is Application Programming Interface. So this and definitely transparency also play a major role. So this the friendliness and ease of use is very important to make the distributed services to be used by wide variety of community members. Transparency, which is hiding inner implementation policy from users, and we have several types of transparencies like access transparency, location transparency, migration transparency, replication transparency, concurrency transparency, failure transparency. So much transparencies are there. Let's see some of them detailedly. At access transparency, we are just hiding the differences in data representation. So as a end user, I know only, and whatever I want, I will get it. Whatever the background process, I just hide it from me. Okay. So location transparency hides differences in location by providing uniform access to data. So we don't know exactly whether the data is residing in this machine or somewhere else. So even I don't want to bother about it because at the end of the day, I need the correct data. So as a end user, as a third party or as the application software, I'll just concentrate and focus on the data rather than where it came from, right? So we are preserving that location transparency. Similarly, we can able to make resources to relocate from one place to another without changing their names. So automatically that is migration transparency. So these are some of the transparencies. Then next one is scalability and modularity. The algorithms, data, and service must be as distributed as possible. Various techniques such as replication, caching, cache management, and asynchronous processing help to achieve this scalability. Okay, so these topics come under issues related to system and operating system design. Next one is algorithmic challenges in distributed computing. So first one is designing useful execution models and frameworks. See, definitely we need to create a model or a demo-like thing before going for the complex system. So automatically, that interleaving model or partial order model or input-output automator model or the temporal logic of actions are some of the best examples for model generation or the models that provide different degree of infrastructure. Okay, just to give a overview about the system. Then dynamic distributed graph algorithms and distributed routing algorithm. So definitely we are going to use a lot of graph algorithm and routing algorithm. How exactly the dynamic algorithms play a major role in distributed system. That's what here we are concentrating. So graph algorithm, they are based for the large number of higher level communication, data dissemination, object location, and object search functions. So these algorithms must have the capacity to deal with highly dynamic graph characteristics. They are expected to function like routing algorithms. The performance of this algorithm has different impact on user perceived latency, data traffic, and load in the network. Okay. Next one is time and the global state in a distributed system. The geographically remote resources demand the synchronization based on logical time. Logical time is relative and eliminates the overheads of providing physical time for applications. Logical time can capture the logic and interprocess dependencies, track the relative progress at each process. Moreover, maintaining the global state of the system across phase involves the role of time dimension for consistency. Deriving appropriate measures of concurrency also involve the time dimension, as the execution and communication speed of threads may vary a lot. Synchronization or coordination mechanism. Synchronization is essential for the distributed processes to facilitate concurrent execution without affecting other processes. The synchronization mechanism also involve resource management and concurrency management mechanisms. Okay, like physical clock synchronization, leader election, mutual exclusion, deadlock detection and resolution, termination detection, garbage collection, group communication, multicast, ordered message delivery. So everything is come under time and global state in a distributed system. Okay. Then synchronization or coordination scheme. Yeah, that's what we discussed. So this group communication, multicast, ordered message delivery, everything come under this group communication. Monitoring distributed events and predicates. Predicates defined on program variables that are local to different processes are used for specifying conditions on the global system state. Online algorithms for monitoring such predicates are very, very important things. Similarly, an important paradigm for monitoring distributed event is that of event streaming, wherein streams of relevant events reported from different processes are examined collectively to detect predicates. Okay. Next one is distributed program design and verification tool. Methodically designed and verifiably correct programs can generally greatly reduce the overhead of software design, debugging, and engineering. So definitely designing play a big challenge. Debugging distributed system. Debugging distributed system is much harder because of the concurrency and replications. Educate debugging mechanisms and tools are needed definitely, and several open source such methodologies are available. Next one is data replication, consistency models, and caching. Fast access to data and other resources is important in distributed systems. Managing replicas and their updates faces concurrency problems. Placement of the replicas in the system is also a challengeable one because resources usually cannot be freely replicated. Okay, then World Wide Web design, caching, searching, scheduling. So WWW is a commonly known distributed system. The issues of object replication and caching, prefetching of objects have to be done on World Wide Web also. Object search and navigating the web are important function in the operation of the web. Distributed shared memory abstraction. A shared memory is easier to implement since it does not involve managing the communication task. The communication is done by the middleware by message passing. The overhead of shared memory is to be dealt by the middleware technology like weight-free algorithms, mutual exclusion, register constructions, reliable and fault-tolerant distributed. Next one is reliable and fault-tolerant distributed system. So here we are imposing several algorithms like consensus algorithm, replication and replica management algorithms, voting and quorum systems, distributed databases and distributed commit protocols. Then we should maintain those as in a distributed database. Maintaining this ACID property is a very tough one, right? What do you mean by ACID properties? That is atomicity, concurrency, isolation, and durability, right? So that also we need to follow. Then self-stabilizing system we can create. So these are the things come under reliable and fault-tolerant distributed system. And definitely we need to think about the real-time scheduling. Real-time scheduling become more challenged when a global view of the system state is absent with more frequent online or dynamic change because everything we are thinking about real-time, right? So automatically the message propagation delay or that will cause so many issues. So we need to take care of that. So that's all about real-time scheduling. Next one is applications of distributed computing and newer challenges. So the deployment environment of distributed system ranges from mobile system to cloud storage. All the environment have their own challenges. Let's see mobile system. Mobile system, it uses wireless communication in a shared broadcast medium. And definitely it has issues related to physical layer. We need to think about the transmission range, power, battery capacity, etc. etc. Isn't it? In a higher level, definitely we need to talk about routing, location management, channel allocation, localization, and position estimation. Apart from these challenges, definitely architectural challenges also play a major one. Then uh, like base station approach, ad hoc network environment. So we know that ad hoc means there is no fixed infrastructure, right? Because it's an infrastructureless approach. Then sensor networks. Sensor is a processor with an electromechanical interface that is capable of sensing physical parameters. So definitely we are having low cost equipment, right? Sensor with limited computational power and battery life. So they are designed to handle streaming data and route it to external computer network and processes. So we need to focus on sensor network issues. Then ubiquitous or pervasive computing. So in ubiquitous system, the processes are embedded in the environment to perform application functions in the background. So best example is intelligent devices that is fixed in your home, smart homes, etc. So they are distributed system with recent advancements operating in wireless environments through actuator mechanisms. Okay, they can be self-organizing and network-centric with limited resources. Next one is peer-to-peer computing. P2P computing is computing over an application layer network where all interactions among the processes are at same level. This is a form of symmetric computation against the client-server paradigm. They are self-organizing with or without regular structure to the network. Okay, but here also we have some challenges, especially object storage mechanism, efficient object lookup, retrieval in a scalable manner. Everything we need to take care of that. Then publish, subscribe, content distribution, and multimedia. The user in present day record only the information of interest. In a dynamic environment where the information constantly fluctuates, there is great demand to publish, similarly subscribe. Publish in the sense an efficient mechanism for distributing this information. Subscribe means it's an efficient mechanism to allow end user to indicate interest in receiving specific kind of information, right? So publish and subscribe. Definitely distributed agents, that is also play a major role. And agents are software process or sometimes robots that move around the system to do specific tasks for which they are programmed. Agent collect and process information and can exchange such information with other agents. Challenges in distributed agent system include coordination mechanism among the agents, controlling the mobility of the agents, their software design and interfaces. Okay. Next one is distributed data mining. So data mining algorithm process large amount of data to detect patterns and trends in the data, right? To mine or extract useful information. So the mining can be done by applying database and AI techniques to a data repository. Grid computing is it's nothing but it is deployed to manage resources. For instance, idle CPU cycle of machines connected to the network will be available to others. So end of the day, we will try to maximum utilize the idle CPUs. Then finally, security in distributed system. The challenges of security in a distributed setting include definitely we need to ensure confidentiality, we need to ensure authentication, we need to ensure the availability, etc., etc. So this can be addressed in a scalable way. So that is the main focus here. So these are the various challenges in distributed system. Thank you.